Okay, so our next speaker is Serban. He's a site reliability engineer at Adobe, where he's part of a small team that manages 30 plus Cassandra clusters for Adobe Audience Manager. Previously, he was a Python programmer, and he's still trying to find out how a developer who preferred SQL databases ended up as an SRE for a Cassandra team. Apart from Cassandra and Python, he's also interested in automating his tasks with Terraform, AWX, and StackStorm. In this talk, he will go through various topics, covering what Adobe has done in more or less different ways than most. So welcome, Serban, and I think we are ready to go. Patrick?
Thank you. It's not about, this presentation is not about Cassandra 4.0, it's about how we are using Cassandra in Adobe, specifically in Audience Manager. Can switch to the next slide. So I think everyone heard about Adobe, but most don't really know about Photoshop, PDF, and other related products, and perhaps Flash, which we don't like to mention. We are doing much more. It's not the time or place to extensively talk about this. Just saying that Audience Manager is counting clicks and cookies. You can find lots more details on we've been using Cassandra since 2011, and the might 2.1.3016. The largest Cassandra deployment in Adobe. We have 900 instances in production, storing 260 terabytes of data, 34 clusters in AWS. So what are we doing different? We do have a large deployment, but others have much larger. So I'll just go through differences. First, the replication factor. We are using replication factor 2 with consistency level 1. And this is possible because we are using the Lambda architecture with the backfill process, pushing the data to Cassandra, which should automatically fix any missed write. This is done through Cassandra streaming, which is much more efficient than regular insert. And there are major improvements on streaming Cassandra 4. We are looking forward to use that. And we are using vNodes with token allocation algorithm. And this creates the replication factor and the usage of vNodes means that there is a significant probability to nodes from different racks or different availability zones in AWS. So it's a significant probability to have them sharing data. So if we lose any two nodes, we are in danger of having availability problems. So we must be very quick of fixing this. We have a fully automated process to help us to replace fully automatically replace the created instances, and there was that bot in the previous screen. Another automation example is a very recent OS major version upgrade. We use the Netflix technique presented at Apache Cassandra 2019 by Joy Lynch and blog post. It's based on overwriting the root device without using or moving the data kept on instance stores. Another difference, we are not using Oracle or open source Java. We are using Azure Java runtime engine, the Postgres garbage collection. It helps a lot, as you can see in the graph, with the 399 response times, and we switched 4 or 5 years ago, and it's been just great. You can see more details in their link there. This was an old situation when we had to perform an intentional split brain, something usually to be avoided in NoSQL databases. We had to add a new deployment in a new AWS region by splitting on already existing one. We extended the existing Cassandra clusters by adding a data center to each deployed in the new region. After they were synchronized, we split the multi-data center clusters in 2 independent clusters, everything in production with no visible impact for the customers. We had some contributions during this time. We raised and fixed some very small Cassandra tickets, some contribution to the infrastructure metric exporter from Prometheus, and some presentation at Strata, DataStax, Apache, and some local events. Thank you.